I'm going to introduce my research with this order. Introduction. Graphite nanoplatelets are widely used in many applications, such as conducting fillers in polymers, hydrogen storage materials, and electrode components in batteries and supercapacitors. Among many other chemical methods to make a graphite nanoplatelet or graphene, I use the graphite intercalation compounds to exfoliate and get a graphite nanoplatelet and I use perchloric acid, and it has a few advantages. First is environmentally benign. When we make a graphite intercalation compounds, we usually use sulfuric acid or nitric acid with some solid type oxidizer, but it doesn't have but it is sulfur free and nitrogen free and easy to separate. As I mentioned, it doesn't have a solid oxidizer. I use perchloric acid and graphite, this binary system without solid oxidizer, and it is time-saving process. Because when we use sulfuric acid or nitric acid with the solid oxidizer, it takes like 16 hours to intercalate. But in case of perchloric acid, it has short intercalating reaction times, like 30 minutes. And advantage of using microwave in expanding step. First, it is simple and easy operation, and if you use a furnace to expand, to exfoliate, you should increase the temperature above 900 degrees Celsius. But I use microwave, safe at room temperature, and low-cost equipment. This is my experimental materials, flake-type graphite and perchloric acid, and I use Marfu furnace for intercalating step and microwave for expanding step. This is the procedure. First, mixing graphite with perchloric acid with that mass ratio, and perchloric acid and graphite is heated in furnace for 30 minutes at 120 degrees Celsius. This is the intercalating reaction. And the third one is washing with DI water and drying to form residue graphite compounds. And then graphite intercalation compound is heated and expanded with microwave for 30 minutes. And expanded graphite is sonicated for 30 minutes in bath type sonicator. I divided my experiment in two steps. First, the synthesis of graphite intercalating compounds, and with this XRD data, I confirmed that the perchloric ions are intercalated between the layers of graphite. And preparation of graphite nanoplatelets. After expanding and exfoliate with microwave, expanded graphite was mixed in ethanol solution, and with the ultrasonic irradiation, it was foliated. As you can see from this photo, macroscopic volume of microwave exfoliated samples increased more than 20 times. This is the GIC graphite intercalation compound, and this is the expanded graphite. And the C is graphite, control graphite. This one is the expanded graphite. Expanded graphite has a bellow-like structure, and porous and cracking structure is observed, but it still have many layers, so individual ships are not formed due to incomplete exfoliation. And with the BT surface area data, I could confirm that graphite has been well expanded, but it still have very low surface area, and pore size was also increased. And this is expanded graphite, and after the sonication, you can see expanded graphite has been turned into foliated sheet by sonication. and particle size of graphite platelets were reduced. And this is XRD data. After intercalating reaction, this 002 peak significantly decreased, and it was left shift. There is a left shift of this peak. So I conclude that increasing interlayer spacing caused by perchlorate ion intercalation, and after the microwave heating, 002P compared with these two was disappeared, and this peak increased in intensity from this intercalated graphite. And this is because vaporization and violent explosion of intercalates causing the exfoliation of graphite, which explains the volume increase and disappearance of that peak. This is my conclusion. Graphite nanoplatelet was prepared by intercalation and microwave exfoliation with perchloric acid. And graphite was very expanded and has increasing pore size and bellow-like structure. But it still has very low value of surface area to use for electrodes. So currently, expanded graphite has not enough surface area for application. So the further exfoliation by in situ intercalation polymerization will be done. Thank you for listening.